All right, let's look at a few problems from chapter 16 here. And starting with number 31, 31 says, find the ratio of the new and old periods of a pendulum if the pendulum is transported from the Earth to the moon, where the acceleration due to gravity is 1.63 meters per second squared. So if you remember from our analysis of a pendulum, we hooked it off to one side, we let it swing back and forth, and we had already done the period of a mass on a spring. And so we kind of compared our equations of motion from the spring to the pendulum and discovered that K over M is actually then the same as L, length of the pendulum, over G, the acceleration. And so there was the comparison, if you will. So, in other words, the longer the period, the longer the length, the more time it takes to swing. Kind of makes sense. And also, the lower the acceleration of gravity. So as this gets smaller, it's not, pulling it back as much. So this period also gets bigger. So I'm going to use this and then point out that this was derived not necessarily on Earth, but in general. So if we said, what is the period on Earth? I'll put a little E. And we say, what is the period on the moon? M. We would get a 2 pi times its length over the G. And I'll say the G on Earth. Because on the moon, then, you would go 2 pi times the square root of its length over G on the moon. So the only difference is the acceleration due to gravity. They make it very clear that the same pendulum, so it's going to keep the same length, is transported to the moon here. And then it asks for the ratio of the new to the old. And I guess, depending on what they mean by new, and I'm pretty sure they want the new to be the period on the moon compared to the period on Earth. So if you put these two on top of each other, they each have a 2 pi. They each have a square root of L. And of course, the difference is this would have a G of the moon and this would have a G of the Earth. So after canceling the 2 pi's and the L and then taking the denominator and flipping it, you're going to get a square root of G on the Earth to G on the moon. And so now we can put in our 9.8 for Earth and our 1/6 of that. And so it's going to be the square root of 6. And so I'll just go 9.8 divided by 1.63. See, there's the 6. And the square root of that is 2.45. All right. Hopefully that one was straightforward.